Hello. So in Energy 101, we're starting to reach the end of the energy sources section. And today we're going to talk about energy prices. Now, we talked about oil prices before and how they're determined, and the fact that it's a worldwide commodity and priced worldwide, whereas other things like natural gas are priced regionally because it can only be transported at a reasonable cost by pipeline. Today we're going to look at the cost of all types of energy sources that we've been covering. Here we're looking at going back to our reference diagram here. We're talking about the natural energy sources. In order to satisfy the energy needs of society, we have to go find forms of energy that occur naturally in the earth. So we're going to be talking about today the prices of these energy sources. And what are they? Just to group them a little bit differently, the Earth's energy supplies that we use in order to satisfy our energy needs are fossil fuels, categorizing them as a whole, that is coal, oil, and natural gas. Coal, oil, and natural gas are the fossil fuels. And we chemically react those, of course, with oxygen in the atmosphere and release the chemical energy as heat in a combustion process. But we get 82% of our energy from fossil fuels, 82%. 9% comes from uranium in the form of nuclear power plants, and then another equal 9% comes from renewable energy, the largest component of that being biomass, as we'll see here in just a minute. And we know that wind is about 10 times what solar is, hydro is significant, and biomass is significant. But as we see on the next slide, you can see it graphically, the percent of energy sources that we use that come from each of these components, this being fossil fuels, nuclear fuels, and renewable fuels. As I mentioned, 82%, 9%, and 9%. And I just thought it was worthwhile to show that, to show how we're so dominantly dependent on fossil fuels that we burn and combust and then convert to other forms of energy that we're going to cover next. And renewables is still a small category. We broke those out earlier, and you can see what those are. But it takes a lot of investment in conversion process plants in order to convert from fossil fuels to another form of fuel. But what I wanted to do today is look at the prices of these energy sources that we depend upon. The prices that you see quoted every day, let's get rid of all the scratching there. The prices that you see quoted every day and talked about on the news might be confusing sometimes, and I wanted to try to clear up some of the confusion that might occur. We hear about oil prices, and oil prices is somewhere around $90. It has fluctuated. Gosh, when I got into the energy area in the 1970s, it was as low as $2 a barrel. $2 a barrel. Of course, the cost of living has increased, and price escalation has gone up, and that's in today's dollars, that's about $8 or $10 a barrel. But today it's about $90. It went as high as about $140 to $150, depending on whether you look at a daily closing or a monthly closing price. But it's fluctuated wildly, and as we'll see here in just a minute. You see natural gas quoted as of right now at the end of 2012, when I'm recording this, at around $3.50 per 1,000 cubic feet. Now, one question that I want to try to answer today is, how do we compare $3.50 per 1,000 cubic feet of natural gas with $90 per barrel of oil? We'll get to that here in just a minute. Coal, you see quoted as about $50 per ton delivered to an electric power plant. I focused on electric power because that's where most of our coal goes. We also use coal for making of iron and steel processes and other industrial processes. But the problem I wanted to try to clear up is how do you compare these prices? Because they're obviously in different units. It's like pricing one thing and by the dozen and another item by the single item. What does it mean there? And going on down the list of these being the fossil fuels, those top three that will all cost us money to get people to get them out of the ground and pay people who own them in the ground and transport them to us. Nuclear. I don't want to get into the nuclear fuel cost. It's a relatively complicated topic. Right now, we're getting about half of our nuclear fuel from the destruction of warheads from the Soviet Union, the previous Soviet Union, Russia. We had a nuclear treaty that which they would disassemble, and we would use the uranium that comes out of the warheads. So things get complicated. But it's inexpensive relative to fossil fuels. It's inexpensive by any measure you want to make. And of course, renewable energy is free. The sun's free. The wind's free. The wood is grown naturally, just out in the woods, and so the renewable energy is certainly nice, but you got to look at the infrastructure you have to build in order to utilize that renewable energy. So those are the energy prices that you see quoted today. But what do they mean on an apples-to-apples basis? Well, in order to do that, we have to look at what are we using those fuels for? Well, we're using them to burn, as I mentioned before, for the heat value, how much heat that we get out of it during the combustion process. And we use that heat for building energy, to heat buildings, to cook with, for industrial drying, like carpet drying. For when you make carpets, you dye them, and then you need to dry them. All kinds of manufacturing processes we have to dry. We burn it in our automobile engines and our diesel engines, fossil fuel for the heat value. The more heat we can release in our cylinders and gas turbines and jet airplanes, the more power we get out. So we're using the combustion heat, thermal energy, the heat energy, and then we burn it in electric power plants, and there again, the amount of electricity we get out is proportional to the amount of heat that we get out of the combustion process. So since we're using all of these for the same purpose, and that is to burn and produce heat, then we want to price it on a per unit of heat basis. And since we're U.S.-centric in this course, we'll price it on a million BTU basis. And that's a number you see quoted in a lot of places. And what is a BTU? A million BTUs is, of course, a million of whatever a BTU is. Well, just for clarification, 1 BTU is defined as the amount of heat that it takes to heat 1 pound of water up 1 degree Fahrenheit. So if you want to heat 1 pound of water up 10 degrees Fahrenheit, it takes 10 BTUs. So, or a million BTUs will heat a million pounds of water up 1 degree Fahrenheit. So that's what a BTU is. And we'll later on get into the conversions of BTUs to kilowatt hours and various things that you see quoted. But these numbers that you see in articles in news and here on the television that they quote are meaningless unless you know how that number compares with something else, or there's a whole, and be able to put it in context. And that is one thing I hope we can accomplish in this course, is try to help you put all this information that you see and read on the news and in the public media, put it in context so that you'll have extract some kind of meaning out of it. Well, here are the prices of the fossil fuels per million BTUs. Per million BTUs. I've converted everything to a million BTU basis. I've got it for natural gas, I got it for oil, I got it for coal, and which supplies 82% of our energy that we use in the U.S. I got it plotted here from 1998 to the end of 1998 to the end of, not quite, it's actually about the middle of 2012. But I show it for demonstration purposes. This starts off that in 1998, the red is oil. Oil was about $2.60 a million BTUs. Natural gas was about $2 a million BTUs right here, and coal was around $1 a million BTUs. Well, coal has been gradually increasing, and these are actual dollars that you would have paid in 1998 or 2003, and without any escalation factors for cost of living. And you can see it's been pretty steady over the years. Natural gas has been rather erratic. The blue line, which is natural gas, here in just a couple of years has shot up from about $3 to about $5. That's almost double. It went back down to about $2.50, and then it went up all the way to about $10 a million BTUs, and since then has dropped back down, and now is around $3.50 at the end of 2012. Well, what about oil? Well, if you look, oil and natural gas track pretty much together between 1998 and 2005. But in 2005, a lot of it due to China's tremendous increase in the use of energy and oil in particular. The world oil price shot up, and everybody was pumping as much oil as they could pump, and it went to, that's when oil went to $140 a barrel, and which corresponds to about $16 a million BTUs, and that was in early 2008. Went up to $16. It was actually a little higher than that if you look at it on a daily basis. And then the recession came. Many people will argue that the recession in the U.S. in particular was due to the high price of energy because it extracted so many dollars out of the economy. And that then put people in a bad way in order to try to pay their home mortgages that they were leveraged out on, and everything started to collapse. But certainly the price of energy was one thing that had something to do with the recession. The best way to kill oil price and oil demand and energy demand in general is to have a recession, and that's what happened here. It went all the way down to about $8 a million BTUs. It was cut in half. And this, again, these are prices I don't show for the scatter that occurs on a daily basis, but this is just on a yearly basis. And since 2008, it's escalated back up, and it went to about $110 a barrel, which is back up to $16, close to $16 a million BTUs, and then today it's down around $15 a million BTUs. Well, the reason I show this chart is because to look at what's the situation when we have when we compare prices. If you got a choice of burning natural gas or burning oil, the choice is obvious if you're interested in money, which being a free enterprise system, and the U.S. in particular we are, and most other countries don't want to spend any more of their money on energy than they need to. You would switch everything to natural gas, and because it's about 4 to 5 times cheaper. Natural gas is about 4 or 5 times cheaper compared to oil, and coal is a little cheaper than natural gas. But when you start looking at all the ramifications, coal puts a floor on natural gas, because when natural gas gets down close to the price of coal, the power plants can turn on their natural gas plants that are not running at that particular time at night and other times when the load is low, and cut down on their coal. And so the coal forms pretty much a floor for natural gas. oil would be the ceiling on natural gas, and it fluctuates in between. But to give you an example of why don't we fuel switch and why aren't we using more natural gas in lieu of the oil that we have, well, you get into the subject of fuel switching. Fuel switching is switching when you switch fuels because one fuel is cheaper than another fuel. And for instance, if you got a fuel that's 4 or 5 times cheaper, it'd be nice to be able to burn it for its heat than burning the one that costs 4 to 5 times more. But what's required when that does not occur is the infrastructure investment is too much to justify the reduced operating cost due to the cheaper fuel. And an example, and we can talk about many examples, but right now people talk about why aren't we converting gasoline cars to natural gas cars. And you can certainly burn natural gas in cars. I was faculty advisor on a student team that competed in a university competition that converted in 1970s. This is in the 1970s, converted a car to run on natural gas and drove it from MIT in Boston to Caltech in Pasadena, California, all the way across the country on natural gas. It can certainly be done, but it requires conversion of the fuel systems from gasoline, or in addition to a gasoline, to natural gas. That requires high pressure tanks and requires somewhere on the order of $5,000 to $10,000 per car. $5,000 to $10,000 per car. DOE estimates it at about $10,000 when you include the refueling stations, the refueling investment, because now you got to have filling stations all around the country to refuel. So fuel switching makes sense, but if you don't have to make too much of an investment to make the switch, from a more expensive fuel to a cheaper fuel. But I wanted to cover that before we left energy sources, to look at the relationship between natural gas, oil, and coal prices on a per unit energy basis, which is what any user looks at when they are trying to determine what type of fuel to use, if they're capable of using a different fuel than what they're doing. House heating is another one. You can heat your house by oil, or you can heat your house by natural gas, but today anybody that has natural gas pipelines running down close to their home is hopefully switched over to natural gas because it's so much cheaper. This is just another example. A few cases where natural gas pipelines are not available to a home and they have no choice but to stay on oil up in the Northeast in particular. Okay, so that covers the pricing of energy and their relative value. Take care. Bye.